Imagine the Earth right now, blue oceans, green forests, teeming with life. Now, erase all of that. Erase the water, the air, and the ground beneath your feet. What you have left is a ball of boiling, molten lava floating in absolute darkness. That was our planet 4 billion years ago. This raises a fundamental question. How did that hellish rock transform into the only known home for life in the universe? Where did our water come from? And how on earth did we get our moon? The answer lies in one of the most violent and fascinating stories ever told, the birth of our solar system. Let's dive in. To find the beginning, we have to go back 4.6 billion years. Before the sun, before the planets, there was no solar system. There was only space, dark, quiet, and empty. But floating in this void was a gigantic, slow-moving cloud of dust and gas. Scientists call this the Solar Nebula. This nebula was mostly hydrogen and helium, and for millions of years, it drifted peacefully. But then, everything changed. A massive star nearby reached the end of its life and exploded in a cataclysmic event called a supernova. This wasn't the Big Bang, but it was just as important for us. The shockwave from that explosion hit our peaceful nebula. It caused the cloud to collapse under its own gravity. It started to spin. As it spun, it flattened into a rotating disk, known as the protoplanetary disk. This is why, today, all of our planets orbit the sun on a relatively flat plane. At the very center of this spinning disk, the pressure and temperature became so intense that they ignited a nuclear furnace. Hydrogen atoms began fusing into helium at 15 million degrees Celsius. Our sun was born. It swallowed up 99.8% of all the material in the nebula, leaving just a tiny fraction, a mere 0.2%, to create everything else. The planets, moons, asteroids, and comets. So, how do you build a planet from just 0.2% of cosmic leftovers? It starts with dust. Imagine tiny particles in that disk, gently bumping into each other. Because of static electricity and chemical bonding, they started to stick together. This process is called accretion. For millions of years, these small clumps grew. They became kilometer-wide objects, called planetesimals, the building blocks of planet. As they grew larger, their own gravity got stronger, pulling in even more material. They became protoplanets, objects as big as our moon. This wasn't a gentle process. These protoplanets were constantly smashing into each other. These weren't fender benders. These were apocalyptic collisions that generated enough heat to melt entire rocks, creating vast oceans of magma. But out of this chaos, gravity began to pull the debris into spheres. After tens of millions of years of this cosmic demolition derby, our Earth began to take shape. This early period, from 4.6 to 4 billion years ago, is known as the Hadean Eon, named after Hades, the Greek god of the underworld. It was truly hellish. The Earth was a scorching ball of magma, constantly bombarded by asteroids, some as big as 200 kilometers across. But here is the incredible twist. This hellish period is the reason we have oceans today. Many of these asteroids and comets that were smashing into Earth were loaded with ice crystals from the outer solar system. When they hit, the heat turned that ice into steam, which rose into the early atmosphere. As the bombardment slowed down, the Earth began to cool. That steam condensed and fell back to the surface as rain. It rained for millions of years, filling the basins that would become our oceans. The water on your lips right now is, in part, 4 billion-year-old comet dust. So, we have a planet and we have oceans. But why does Earth have layers of crust, a mantle, and a core? This happened during the next period, the Hadean Eon, through a process called differentiation. Think of the early Earth as a giant, molten ball of mixed-up ingredients. The heaviest elements, like iron and nickel, began to sink. Pulled by gravity, they flowed down through the magma towards the center. Lighter elements, like silicon and oxygen, floated upwards towards the surface. Over millions of years, the sinking iron and nickel fused together at the center, forming the core. The swirling liquid iron in the outer core acts like a dynamo, generating Earth's magnetic field. This field is our planet's force field, deflecting harmful solar radiation and keeping our atmosphere from being blown away into space. As the lighter elements rose and cooled, they formed the first thin, solid layer, the crust. And in between, the thick, rocky mantle was trapped. In just a few 100 million years, the Earth had organized itself from a ball of chaos into the structured planet we know today. But our planet has a constant companion. Where did the moon come from? The leading theory is the Giant's Impact hypothesis. About 4.5 billion years ago, during the Hadean Eon, there was another protoplanet roaming the solar system. We call it Theia. It was about the size of Mars. Theia was on a collision course with Earth. When they hit, it wasn't a glancing blow. They smashed into each other with unimaginable force. The cores of the two planets merged, which is why Earth is so rich in iron today. But the impact also blasted a massive cloud of debris into orbit around Earth. Over time, gravity pulled this ring of debris together, forming our moon. We know this is likely true because the rocks brought back by Apollo astronauts are almost identical to Earth's. The moon is literally a piece of our ancient, violent past. And this accident was crucial for us. The impact tilted Earth on its axis by 23.5 degrees, giving us our seasons, and the moon's gravity pulls on our oceans, creating the tides that many scientists believe were essential for life to first move from the sea onto the land, from a cloud of dust triggered by an ancient supernova. Through violent collisions and billions of years of organization, our world was built. The sun is at just the right distance. Our magnetic field is just the right strength. Our atmosphere has just the right mix of gases. We have a moon that stabilizes our climate. Everything that happened was exceptionally fantastic. It's a reminder that we live on a rare and precious world, forged in chaos and balanced on a knife's edge. It's our only home, and understanding its violent birth makes protecting it all the more important. Thank you for watching the deep dive. If you want to continue exploring our planet's story, click here to watch my video on the evolution of life on Earth. Don't forget to like and subscribe. See you in the next one.